We're doing a lot of things for the environment here. This is a pear orchard. One thing that's planned is other plants around the bottoms of the trees to put roots in the grounds to harbor microbes, which will help with the hyphae underground to feed the trees. Here you can see the sugar snap peas and some, oh, they bit the dust in the freeze, buckwheat is a cover crop to keep roots in the ground, to keep microbes fed by the photosynthesis from the plants. Here we have fennel, and in between the fennel we have potatoes planted so that we have a combination of different types of plants. Over here is a cherry bush. Here's some young chard. What you can't see are the potatoes in between. The reason we're putting different plants together is because each kind of plant harbors a certain kind of microbe, and those microbes can work together and make the plants even healthier and sequester more carbon. Here's the mycorrhizal fungi that we grew last year, and never had it analyzed, but I'm assuming it's okay. This is our Johnson Sioux compost inoculant from last year. 2 pounds of this will inoculate an entire acre with a higher percentage of fungi. Fungi leave their body parts left in the soil as carbon, and it makes the soil spongy. That holds water, and of course it holds carbon. Here's this year's Johnson Sioux bioreactor. It's a stationary pile. It doesn't get turned. These holes that you see, I hope you can see, these holes ventilate the pile all the time. So no part of the pile is more than a foot away from air. And we need a lot of moisture. So here's a water tank that we fill every day. We want to keep the water level at about 70%, and that will ensure that the fungal will have dominance over bacteria. And then we put worms in it. They like that moisture too, and they'll crawl around and move the microbes throughout the pile. And then that material that you just saw in the last clip was the leftovers from last year. This is our charcoal making operation. We gather sticks from neighbors. We bring them over here and we char them in this kiln, and there's a bigger one over here, but don't use it too often. There's some nice plants to help our plant diversity, different herbs. So then we take the charcoal, which you can see is in big pieces. There's my hand in comparison. And then we grind it in this. And this grinder is hand powered, and it wears us out. So we're trying to figure out how to get a bicycle hooked up to it so we don't use a lot of gasoline to run it. This is our compost pile under here that we mix with the charcoal. If you put charcoal in the ground without inoculating it with different minerals that are in the compost and organisms that are also in the compost, the the lack of minerals, the charcoal will seek the minerals that are in the soil already, and your plants won't won't be very big. So we mix the two together. One other note about the charcoal is that something happens in the process of making it when it gets heated up to 12, 13, 1400 degrees. It changes it in some way, and the bacteria that would normally eat it if it were wood cannot eat it, so that the charcoal stays in the ground for up to 5,000 years. In the Amazon, they have tested the carbon dated it, and some of it's 5,000 and even older years old. So that would take it out of the cycle where it puts it back up in the atmosphere. And we're going to treat lawns in the neighborhood with this material, and then the Johnson Sioux on top of that. Here you can see where we're tearing up a barrier, a weed barrier that we had as a path. And what we're going to put in place of it are a cocktail of low-growing plants that together will put carbon in the soil, and they'll cause a fungal dominance to do that. And then, so we're going to be sequestering carbon, and then the carbon, you know how the small fungi send out hyphae. They're little tubes that go out, and they can actually feed some of the plants in the beds. And in between, we try to grow things in the beds, and we're getting this same cocktail of seeds will be used in between beds to do the same thing. And their hyphae the hyphae of the fungus will reach out into the bed next to it on either side and feed the plants. Now, if we do this, we can eliminate the use of even nitrogen as a fertilizer because the plants can supply that all on their own if they're grown in communities. It's kind of like a little social thing going on. They actually have a quorum behavior where when they reach a certain number, they can work together and do things that they can't do when they're alone. It's pretty amazing. I suggest you study it, but there you go. In order that the Johnson Sioux inoculant goes down in and touches the roots, we're going to use this device. You can put a cement block on it to make it heavier, and those spikes on the front of it go down and pierce the soil. And so that inoculant will go down and embrace the roots of the existing plants. We're going to do that on some lawns in the neighborhood as well. This bed is a future site of a cocktail of some 40 seeds of warm season plants. It will include flowers and vegetables. All those plants go together again and enrich the fungal content of the soil, sequestering carbon, making the carbon spongy so it will hold water. Now, one of the reasons we want it to hold water is that the way agriculture works with bare soil, such as you see right here, that lets off water. If it were covered with green, like this bed over here, not so much water gets out. And not only that, photosynthesis is working 24/7. Well, yeah, it has nighttime activity too, but it's not collecting any energy from the sun at that point. But it is still helping sequester carbon. Plants squirt a tremendous amount of the sugars that they make from the photosynthesis right into the soil, and they're feeding these bacteria, which in turn bring minerals and water into them. Here are two examples of hose end sprayers that we mix a little humate in, or humic acid in the water to nullify the chlorine in our water, since we're really raising microbes who are the real gardeners. We want to treat them as well as we can. So then we put the Johnson Sioux inoculant in there as well, and that's what I water the compost pile over there with as well. Under the tarp are sticks that are ready to be made into char. This is a very good kind. This one's kind of, you got to be very careful with it. I broke the whole handle off of it because it fell over. So this one's very expensive, but I think it will be very good. So this garden is our experimental area where we have other gardeners come in to help and to learn and to take home vegetables. And so it's a place where humans are using nature to get food, and a little mindfulness as we work in the garden quietly together. So in a minute I'll show you another possibility. This is our old pickup, where we pick up sticks from the neighbors to make biochar out of, and we can redistribute some of that and put some of it in gardens. So, and then over here is where I live and where the Heartland All Species Project office is. And this is called the Urban Wilderness. And I'm approaching the gate now. Now, we have sequestered quite a bit of carbon in the 40 years that it's been here. And here's a little thing you can read. Nature is the first teacher of presence. Enter the woods, leave thought behind, and sense what surrounds you. Let it fill you. So you can just kind of feel some of this as you walk up. Spring is here. In about 2-3 weeks, this is going to be magnificent beyond belief. And you'll really feel this energy. So everyone can do what they can do. Get quiet, go inside, think about it, think about what you can do.